Okay. You can use Python as a kind of dumb calculator. So if you write something like 2 times 3, say, in a line and hit run, it does absolutely nothing. Why does it do absolutely nothing?
No print.
Yeah, there's no output command, right?
So wait, but if you say x equals 2 times 3 and then put print x?
Yep, so I could do x equals 2 times 3 and then do print x. Oops. And you still need params. Then I could get this out. You will see some places claims, like if you read a bunch of stuff about Python, if you go Googling for Python, you'll see people say that that will work. And the reason that they're saying that will work is they're running an interactive version of Python, and what we're running is Python scripting.
So
Okay.
can you use this to solve pretty advanced algorithms?
Yeah, Python's nice for doing math in. One, because it's fast. Like, it's fast to write Python code. It's pretty chill. Python also has imports for a number of different very nice math libraries. One of the things I'm going to show you is that it very handily supports dealing with complex numbers. So if you want to deal with, just for kicks, 1 plus 1i. So that would be 1 plus the square root of -1. You can do that here. If you want to do, say, y is 3 plus 2i, or minus 2i maybe, and then print out x times y, it'll very happily do complex arithmetic for you. So this comes in handy, especially, like, this is where my experience with Python lies.
Wow.
You alive?
Nope, I'm looking at the diagram.
Okay. Other math things you can do. Other math things you can do. Should be noted, very convenient. If you do, say, x is j, it doesn't like that. That's not very convenient. I lied. X is 1j is very convenient. So that would be x is mathematically I, right? It's the square root of -1. If you want to do something like demonstrate that that's true, you could do x is x squared.
Wait, hang on a second. What's j? What's the constant j?
The constant j in here is the complex square root of -1.
Why is it I?
Because I is used for iteration in computer science, and so, yeah.
Okay, so that is equal to imaginary.
Yeah, so this is the imaginary I, and then this is how you do squaring.
Which does not work in Java.
So x times 2 would be multiplied by 2. X times 2 is x to the power of 2. So I should get -1 plus 0j out of this. If you want to maybe do this with, like, numbers that you know and love.
Complex and real component, doesn't it?
Yes.
That's really nice.
So if you want to do this with numbers that you know and love, like 3 raised to the 4th is 81, because it's 3 times 3 times 3 times 3. Python is very convenient as far as division goes. If you do something like x is 3 over 4, in some languages this would return. How many times does 4 fit into 3? 0. So in some languages this would do integer math and return 0. In Python this just very happily converts to a float. If you want it to do integer math for some reason, if you throw a second divide in there, it'll force it to do integer math. How's your bee sting doing?
It's a little red, but it's not swollen.
Cool. Good talk. Okay, let's see. Another one that's useful is the Modulo command, which actually works here. So if you want to know what the remainder is when you divide 425 by 4, you should get 1 PS. That's because 400 is an even multiple of 4, right? So it counts for nothing. And then 24 is 4 times 6, so that counts for nothing. You're left with 1. So if you want to know two things, right? Like 425 divided by 4 and the remainder. Oops. We need to clearly print y. So this will tell me how many times did it evenly go in and what was left. Right, so 425 is 106 times 4 plus 1. You guys cool with that? The nice thing about this is that it's actually a modulo operator as opposed to processing's nonsense broken modulo operator, which is actually a remainder operator. If you put a minus in here, it will in fact give you a reasonable answer as opposed to giving you negative something. Cool. So we use that for screen wrapping, right? So you would use that for the same thing here, right? To keep something on the screen or to make sure that something stays within a bounded set of values. The modulo command is really nice for that. Cool. Good. Questions on math in here? What? Math, exactly. If you need more math, there is a math library that you can import into Python. Like if you need sine and cosine, you'll probably have to go to the math library. If you wanted to import something like that, just type import math. And then it tells you that math isn't used. So then you maybe say something like x is math dot cosine of 6 or something. You'll notice this still works in radians, I think. So that's where those functions are. Use them as you so desire.